Hey, 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 what's going on? This is Drunk College here with another episode. I am Carly and I am drinking a Stewart Spike Seltzer.
Alex, I just elbowed the wall. I'm drinking juice with Prosecco in it, and I also have wine.
I'm Kelsey. I'm drinking the usual, that $4.50 shit. And we have a guest.
Oh yeah, I'm Steve. I'm drinking a Keystone, which is like cheaper Bud Light somehow.
Ew.
Good old piss
Red
beer.
water? Yeah.
So what do you have for us this week, Kelsey?
We're gonna be having a group discussion on whether or not we should pump all of the CO2 into the ocean. This is based on my favorite paper that I have read in grad school so far. I think Alex will like it. It's very sustainability based.
Yeah, no, I could tell. By the question, I'm like, probably not, but
I don't know. I lean more towards.
I mean, like, there's things I could see it helping with. I don't know as much ocean stuff.
But you, I'm sure you've learned about carbon sequestration. That's
no, like I said, no,
like
yes, like I'm saying. I that's what I figured you were talking about. I don't know about like how that affects ocean chemistry and stuff specifically. I know you can put CO2 in the ocean, but I don't know if my only concern was I don't know if there's where that's going to affect anything bad.
And for the rest of the audience, which includes me and Steve and everyone else listening, we have no idea what the hell they're going to be talking about. So I'll probably just end up drawing sea animals.
I feel like I wandered into one of Kelsey and I's like midnight conversations when we were roommates.
That's
what
I was hoping.
Yeah, I'm in the social
science.
Carly,
you're gonna know enough about carbon sequestration by the end of this to have.
I don't even know what the hell you just said, so this is gonna be interesting.
I'm gonna teach you. So first, the problem that this is trying to solve is the greenhouse gas problem. Carly, what do you know about greenhouse gases?
Oh,
come on.
You are roommates with a sustainability major. You should know at least a little bit.
Didn't Al Gore have something to do with this?
Yes. Al Gore calls every single greenhouse gas. It's all his fault.
Technically not wrong initially.
I have my issues with Al Gore. We already discussed this.
The greenhouse gases are things like CO2 that are increasing in the atmosphere, which is what this terrifying graph is here. The carbon dioxide in the atmosphere has almost doubled since the 1800s. So it used to be in like the 200 parts per million, and you can see in the graph it's at blaze at 420 parts per million as of last year. Yes. Okay, so methane is one of the greenhouse gases. Thank you, Alex. Yeah, so I'm mostly talking about CO2 here, but there is also methane. Al Gore versus
there are more. I just thought that was funny.
Yeah, methane is one of them. Al Gore versus the greenhouse gas. That's my favorite WWE match, I think.
Who's ready to rumble?
So the ocean, which is what we're talking about today, absorbs a third of the carbon dioxide in the atmosphere. Does methane come from socks? I'm confused.
Sulfur oxides.
Socks. I get it now. So the ocean absorbs a third of this carbon dioxide, and you might think that's great. The ocean's so fucking big, it's just gonna dissolve in all of that water and mean absolutely nothing, and you would be wrong if you thought that, because that's just not how ocean mixing works. Things don't just dissolve through the entire ocean like that because of the way that different water masses mix. So the surface ocean ends up accumulating a ton of carbon dioxide, which is really bad for reasons that I will explain later. And this is just a brief description of what greenhouse gases do, in case you didn't know. They're what traps the heat on the earth, which is good because it's what lets us live here. But it's not good when there's a lot of it. Like how you kind of want your house to have heating, but that doesn't mean you're going to keep your thermostat on 90 degrees all year round. You know what I mean?
You could also just light your house on fire too.
I think they did that in the old days.
Just all of the house or part of it? Because you got to consolidate.
Cut your neighbor's house down.
Yeah, that'll keep you light your neighbor's house down to keep yourself warm. That could be like a saying, like words to live by. That if you're cold, you should just burn your neighbor's house down. So by the next half century, the average global temperature will rise by 1 degree Celsius. These are just some scary climate change facts. you're not an environmental scientist, like the average temperature for the entire world going up by a degree is a really big deal. I promise.
Normally go up that quickly at all.
It does. Yeah, going up within less than a century by a degree is like a lot for an average of the entire world.
Yes.
And the other scary thing, which is why people are talking about carbon sequestration, is that a third of the warming will be from gases that we've already released. So even if we completely stopped releasing greenhouse gases today, we would still get a third of the temperature increase that we're expecting.
I need to stop.
Yeah. And these are just some of the outcomes. Obviously, the temperatures go up. I'm going to talk about ocean acidification later, which is bad because a lot of organisms will literally dissolve if the ocean's too acidic.
What?
Yeah.
What kinds will dissolve?
Things that build shells, so like oysters, their shells the larvae won't be able to build the shells because they'll dissolve in the water if the water has too much acid.
I mean, a lot of them will just die too because they can't live in certain climates.
Yeah, but I mean the temperatures and stuff is a problem in the first place, but they like won't even survive to adulthood in the first place. It gets like after a certain pH, it gets physically impossible to build a shell. And then the obviously the ice caps melting and the sea levels rising, and then more intense weather events. So if it feels like you've seen a lot more Category 5 hurricanes in the past few years, you probably have. And things like El Niños. Do you know what an El Niño is, the non-science people?
I've heard of it.
I know what it is.
El Niño is when the ocean currents kind of change and it makes the like really rapid warming occur. So one thing that drives me fucking bonkers is when people say, oh, this like bad thing that happened, like this coral dying event wasn't because of climate change. It was just because there was an El Nino that year, because more and worse El Ninos are literally part of climate change. So
Which makes sense.
it doesn't really make, it's not really a valid argument to say that was just an El Nino that year, not a real climate change, because climate change is giving us more El Ninos.
I feel like they can't even really say anymore that like, oh, it's just one event, because like you could say, oh, we just had one like Hurricane Katrina, but then we had Sandy and like how many other hurricanes since then that have like caused significant damage.
It's also like not just that, like that stuff can technically happen at any point. It's the frequency of it is increasing and they're getting worse.
Well, no, that's what I'm saying, because Katrina was kind of like one of those things where it was supposed to happen like every 100 years or like more than that. And now it's like, no, it's like every year we have like a possibility of 3 or 4 of them happening at like almost to that degree.
Yeah, which is also why it doesn't mean anything when you have a snowstorm. If you're having significantly fewer snowstorms, you know, when people are like, it's so cold here right now. So
yeah, also, you know, weather is still even if the climate is changing.
Yeah, kind of like
have extreme versions of cold weather as well.
Even if you go back to this graph, you see the red line goes like up and down constantly. So you can't say that because the red line went down a little bit now that it's not like really an issue. You have to look at the black line. If that makes sense. So what's the solution to all of this? Well, some oceanographers were like, what if we just took the CO2 from the air and put it in the ocean instead?
Which I could see being good depending on how you do it.
Yeah.
What are the consequences of this though?
Oh, we're going to go over it. So
I already have the sustainability mind. Like I said, I know a little less about the ocean, but I've already like through half of this being like, well, this could happen or this could happen. Or like
yeah, so this is kind of a high risk, high reward thing. It's like we don't really know what will happen. We know that it'll get the CO2 out of the atmosphere. We don't know what will happen after that.
How do you even do that? Do you get like big vacuums?
So
kinda.
Big pipes.
big pipes.
The image is an over exaggeration. It's not really like Jack and the Beanstalk pipes from the sky, but that's always what I picture when I'm reading about this stuff. It's just like a giant pipe from the sky. But it would be pipes. Well, there's different methods, but mostly what I was reading about is that you could use pipes to pull it out of the air and push it all the way down to the seafloor. And we already have pipes that like we know would be able to do that. They're just not being used for this yet. We have to do it on a larger scale. So basically what you would do is that you would either put it like deep into the sediment, which is what sequestration is, where it would form hydrates. I don't know much about hydrates except that they exist at the bottom of the ocean. Alex probably knows more about what a hydrate is.
I don't know a ton about that specific molecule. I don't use them.
Okay. It's just like these like dense, almost solid things that form from gases at the bottom of the ocean.
Yeah, I kind of figured it was something like that, but like we haven't talked a lot of specifics about them.
I know there's a lot of methane hydrates at the bottom of the ocean. But so
you
you'd
talk
either
about the ocean.
yeah.
I mean, when we talk about the ocean, it's much more like this could kill fish, and then that's it. You know what I mean? Like this could.
I'm surprised you don't talk more about the ocean and sustainability.
Well, I'm just we learn some basic, like I know about like ocean acidification and like like
okay, we're gonna talk about
bleaching.
A little more later.
Like I said, we talk about that stuff, but like the ocean in much more detail than I do. We talk about more like specific sustainability impacts. Like this could kill stuff in the ocean, and then we talk a little bit in detail, and then we move on. Like.
I mean, we're already killing the ocean. We might as well just kill it some more.
Not a good idea. So we would either put it into the soils where it would form hydrates or put it into these underwater pools. So think like the beach at SpongeBob, the Goo Lagoon. So I know it probably seems like a ridiculous concept when you're watching it, but that's actually like a real thing. Like there's these, they're called brine pools, where the water is so much saltier than the surrounding water that it makes like essentially a lake on the seafloor. That if you were there, it would look like Goo Lagoon.
See, my brain, when you said like pool underwater, I wasn't thinking of like that where it's literally water underwater. My brain initially went to the mermaids from H2O when they went underwater and had that little pool in a cave.
That show slaps. No, that was just in a cave. That was also
I know, I'm like, that's just a pool in a cave.
But I mean like really in the ocean. Like there's lakes of water that are way more dense than the surrounding water. So one of the ideas is to put the CO2 into that, and then it wouldn't diffuse into the rest of the ocean that easily, because it would be in water that's so dense that it's not mixing with everything around it.
Isn't that when the Pacific meets the Atlantic, there are two different densities?
Yeah. That's also why I said in the beginning that the ocean absorbing CO2, like it's not all just gonna diffuse through the whole ocean evenly, because there's a bunch of water masses like that are not interacting with each other. And so the idea is that if you like put it into these pools and stuff, it would take maybe like thousands of years for it to start diffusing back into the pelagic waters, which is like the open ocean. We think everything. That's the problem, is everything's like we think, because we've never done this.
Well, because my brain first went to like, how stable are those? Because I know on ground for carbon sequestration, one of the concerns for it is, yeah, you could put it in geological formations under the ground. Those are usually pretty stable. But if something moves, you could just get however many years of CO2 going back in the air suddenly.
Yeah, there's a lot of problems with carbon sequestration, although I believe it's, in theory, it would work a lot better in the ocean than it would on land.
Yeah, that's why I was just curious, because I know on land, like it's pretty likely gonna move or like for a long time, but we don't really know for sure.
Because from what I know, they've pretty much given up on carbon sequestration on land, but they're still discussing it in the ocean. We know it would eventually fuck up the ocean. We don't know for sure how long it would take to fuck up the ocean. So it's something that's probably going to happen. If we're at like a last resort, we need to do something to buy us more time immediately. So one of the problems with it is that CO2 acidifies the water. Alex, do you remember your carbonate bicarbonate buffer system?
Vaguely.
Biochem?
I'm not biochem. I know generally about acidification, but
well, it's the same. My favorite thing about it is that it's the same buffer system that exists in your blood.
Okay, yeah.
So basically,
I'm
CO2,
like, okay, yeah, I remember that.
Yeah, so the same thing that maintains the pH balance in the ocean maintains the pH balance in your body. So the carbon dioxide combines with water and it makes an acid. But that means that if you like overwhelm this side of the equation with CO2, you're making a fuck ton of acid. So like I said, the idea is that if you put it into the very bottom of the ocean in the right places, it won't acidify the rest of the water, but like there's still things living down there. And that's really one of the big questions is like how much are the deep sea ecosystems connected to the ecosystems that we depend on in the ocean?
Tell you what, Godzilla.
I feel like in some cases you may be able to do it somewhat strategically if there's like an area that's lower in CO2 for some reason, but I feel like that's also difficult because it's going to disperse eventually.
Well, that's why they're like looking at specifically putting it deep into the soil or into those really dense pools to like limit the dispersal, but everything's going to come back eventually.
Yeah.
It's just like
there's areas you could probably put it that like, you know, the CO2 is lower and where it's not like already like acidifying too much. But
yeah,
like,
that's true.
Eventually it's gonna disperse.
It's just like with everything that we know about the seafloor, which is not that much, how many places are we going to find that are both like places that you can sequester it, like those dense pools, and also places that we know there's not heavy CO2? Like,
Did I ever tell you guys that my great grandfather took Babe Ruth duck hunting?
Is that related?
Yeah, because my great grandfather, he was a bayman. So, you know, like ocean, it just reminded me of it.
This is more related.
That's cool.
My dad has Kevin Bacon's phone number.
Did we ever determine if Sir Francis Bacon is the same lineage as Kevin Bacon?
We should make a presentation on that, trying to figure that out.
Yeah.
The Kevin Bacon lineage.
So Kevin, if you're listening to this, I'm really sorry.
We should tweet this to Kevin Bacon.
Oh, Kevin. Can we figure out if you're related to this other bacon dude?
The end of the episode, I'll leave his number.
Okay, so one of the things that's in the deep ocean, does anyone know what foraminifera are?
I don't.
What did you say?
Foraminifera. One of my favorite words.
Wait, say that again. I'm sorry. My dad just coughed, and when he coughs, he does it really loud.
I'm gonna type it too. Foraminifera. Let me type.
I googled is Sir Francis Bacon related to Kevin Bacon.
What is that?
No, I like how the first thing that comes up is Francis Bacon in parentheses, who a quick Google search will reveal is not related to Kevin Bacon.
Damn it. That's annoying.
Yeah, it's foraminifera. They're tiny plankton that live in the soil in the deep, deep ocean, and they build shells, so they're susceptible to things being too acidic would hurt them, and they're really important to the soil health. They're in, you know what plankton are?
Yes.
They're little plankton. They're important in the soil, and they're in like limestone and stuff. We know what limestone is?
Yes.
It's made of things like foraminifera. Yes, exactly. So there's been a lot of experiments on if it would kill them or not, and it's very species dependent, so it will kill some of them like immediately. So another aspect of this where we're like, it might like it kind of kills some of them. So even in like the deep soils at the very bottom of the ocean, there's still things that are trying to live there. Why is my slide not moving?
Yeah, the goal should be to kill as little things as possible.
Yeah. Well, that's the problem is that like there's like nowhere you can really put the carbon dioxide that there's actually nothing. Like there's just life everywhere. Yeah, I did choose this photo somewhat intentionally, but it's baking soda. So one of the potential solutions that this paper is talking about is like if we put all of this carbon dioxide into the water and it would make the water too acidic, then what if we just dumped a bunch of salts in the water because they neutralize acid? But
mixed properly.
So you wouldn't actually use baking soda for it, but that's just what I think of, because for anyone who's not sciencey, baking soda is one of the things that was in that equation. It's bicarbonate, and that like neutralizes the acid. What is that, Alex? Oh, is that a no?
Yeah. No, I was laughing at this.
So had you said something? Did you say it wouldn't mix right, Alex?
Yeah.
Yeah, so that's kind of correct. We would have to use a different salt because there's actually too much baking soda in the ocean already. That it wouldn't, because baking soda is sodium bicarbonate. Those are two of the most common ions in the ocean. So the ocean.
I just never thought about that.
Yeah, so the ocean's actually oversaturated with baking soda, so it wouldn't dissolve. But we could use other salts that would accomplish the same thing. But then that changes the salinity of the ocean, which is why I thought this whole paper was ridiculous, because it was like, we're putting too much CO2 into the air. What if we put it into the ocean? Then it gets too acidic. What if we added more bases? Then it gets too salty. And it just kept going. Like, well, then we'll do this. And then that'll fuck things up more. So then we'll do this.
Yeah, that's basically what I was thinking. Like, I felt like it would just, it would mess something else up if you kept trying to like put things in there.
Yeah, this whole paper was like, well, if it had this effect, we would do this then. And then we'd have to do this to fix that. And it was like, when does the human interference end?
We're just
Like,
vandalizing
the
it.
ocean and stuff kind of fixes itself. Like,
when it has enough time to fix itself. Carly, what do you need me to slow down on? Do you need something
You
repeated?
were going really fast there. I just want to make sure
Sorry.
you're right.
yeah, that meant like the ocean's one of those things that like it's supposed to kind of regulate itself for the most part over time. And if you just go checking stuff in there, start fucking things up.
Yeah, I mean, it's like if you eat something acidic, your body, like, you might get heartburn and then your body will regulate it. But if you like just chug hydrochloric acid, you're gonna die.
My favorite.
Did you say what flavor?
I said my favorite.
I thought you were like, well, if it's a flavored hydrochloric acid, I'll try it.
Don't drink hydrochloric acid. But now, like, it just got me thinking, what malaria could you drink and survive? Very high.
I'm sure they've done fucked up experiments on rabbits with that. So will we ever really do this? Well, we've done like many experiments of it. They've done ones to see if it can be done in like micro scales. And then
Look up and see Steve everyone hit what.
And they've done experiments to see if it would kill the foraminifera, which, like I said, is like sometimes it kills the foraminifera and sometimes it doesn't. We do know that we have the technology to do this. So this is theoretically very, very possible. So the reason I put PETA on there is that the only reason really that we haven't tried this on a large scale is because it's illegal in most places. So the PETA joke was just because it's blocked by like environmental laws. So I just wanted to put a PETA meme on there. By the way, this was a real thing. PETA was really comparing Steve Irwin to Hitler.
I'm not shocked.
Yeah, so pretty much the only reason that we're not doing this is because countries' governments are like, we're not letting you do that here. So they will let companies put as much carbon dioxide as they want into the atmosphere, but they won't let scientists take it out of the atmosphere. So my last slide is just what do you think about, should we do this?
Probably not.
I think we're gonna have no choice one day.
I mean, maybe, yeah. I mean, I think we should switch to renewables or something first.
What is that?
Immediately,
No.
but
Gonna
not.
happen?
Well, no. Well, let's.
Yeah.
I don't think it's gonna happen slower than it needs to be. But I feel like that's what we need to do.
Well, this is
There
like,
needs to be a systematic change, but that's not going to happen.
that's kind of what, like, the oceanographers aren't like stupid and against renewable energy. We're just
No,
like,
I didn't think that.
it's like renewable energy is not going to happen. Like, if we're at the point of no return, what the fuck else are we supposed to do?
Oh
That's
no,
kinda
like
what this
if we
is.
don't have a lot left to do, I don't think sequestration is the worst option.
This is like a last resort, I think. But I think we might end up at the last resort eventually. I want to make a quick pitch here to not take fucking cruises. Did you know the biggest cruise line industries produce as much fossil fuels as like the United States as a whole? And they dump their waste into the ocean, like through the whole cruise, and pick up a bunch of invasive species and stuff that they transport. Carly, it's a little late for Down the Bush.
I put that.
Bye, guys.
Bye.
Save the ocean or I'll kill you.
Oh, you can add emojis.
This was Drunk College. Because no one
Oh, bye.